rules go. Lithium, sodium, potassium, rubidium, cesium, and francium. What charge do they have? Positive 1. Now people, I know of no known examples where that don't happen. What's the charge here? Plus 2. I know of no known examples where that don't happen. What's the charge here with fluorine? I know of no known examples where that don't happen. Everything else up there is up in the air. Okay? So how would you go about figuring it out? Well, let's look at something like chlorine. All right? If we look at chlorine here and sodium chloride, okay, what charge does sodium have? What charge does chlorine have? You guys see that? Sodium has a +1 charge. What charge does chlorine have then? -1. So we're going to put chlorine with a -1 charge. Is anybody confused about that? Okay. Let's look at bleach. NaOCl. This is called sodium hypochlorite. Okay. What charge does sodium have? +1. What charge does oxygen typically have? And what charge does chlorine have? What's that now? Well, now wait a minute. What does this whole thing have to add up to be? 0. There's no charge here, right? On this molecule, on this compound. Is there a charge there? No, it's neutral. Is there a charge here? No. So that means this chlorine's got to be what to equal 0? +1. Whoa, wait a minute. What are you talking about? All right, chlorine's got a +1. Let's take a look at this one. This one right here is called sodium chlorite, ITE. Now what charge does everything have to have on it when we're done? 0. So let's go ahead and put that on the right hand side. Everything's got to add up to be 0. Look in the periodic table, what charge does sodium have? +1. Now, what charge does oxygen typically have? -2. Okay, how many oxygens are there? 2. So that means that's a total of what? Okay, what number has to be going right there to make this guy equal to 0? You with me? We go right down the hallway, we'll find something called sodium chlorate. Let's do the same thing. Chlorine has to have, sodium has to have what type of a charge? All right. We're left with a blank. What does oxygen have to have? -2, right? And there's 3 of them, so that means there's a total contribution of -6. What goes in that blank right there? Oh, let's do one more. The sodium perchlorate. Okay, the whole thing has to equal 0. Sodium is a +1, plus chlorine, and oxygens are what? -2, but there's how many of them? 4. Okay, what number needs to go there? Now looking at John's periodic table, which is not up here now. John, is there a plus and -1 there? Is there a +3, a +5, and a +7 for chlorine? And there's examples of all of them. Sodium chloride, sodium hypochlorite, sodium chlorite, sodium chlorate, and sodium perchlorate. Boom, 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 boom. Now would you think the chemistry of all of these things are different or the same? Oh yeah, major difference. When you start having oxidation number differences, there's huge differences in the chemistry. Sodium perchlorate has an oxidation state of +7 in chlorine. That behaves completely different than good old-fashioned sodium chloride. Okay? So that's how you go about figuring this out if you've only got a couple of things to go with. Now let's take something common. Let's take water. Okay? Now what charge is on hydrogen, you think? +1. Is everybody happy with that? So what charge has to be on oxygen? Well, if it's a -1, then the whole thing would not add up. -2. Does everybody see that? Well, does that look normal? Hydrogen has a +1, and oxygen has a, is that normal? It's normal. Okay, let's go to the medicine cabinet, and let's pick up this guy right here. Now this guy right here is called hydrogen peroxide, H2O2. What charge does hydrogen have? And what does that mean each of these oxygens have to say? -1. John, looking in your periodic table, do you see a -1 listed beside oxygen as well? Yep. Okay, here's what's going on. Oxygen's most common thing to do is -2. If you had a whole room of compounds, they'd fill up most of the room. There'd be a little bitty tiny bit of the corner over here that had your peroxides and things like that in it. All right. Now what about fluorine? What charge does fluorine always go? -1. Always, right? Okay. OF2. Okay. So that's -1. How many of them are there? -2. What does that mean this oxygen has to be? +2. John, do you see a +2 on our periodic table? For oxygen? No.
Yeah.
No +2. Is your +2 on there?
No.
Nope.
-2 -1.
-2, -1. No +2 on there. This is a component of rocket fuel here. As you can imagine, such the unusual scenario. Now, would you think that rocket fuel and hot water would behave differently? Certainly. Certainly. Check out the oxidation number differences. The same way here with hydrogen peroxide and water. You think they behave differently? Naturally they do. All right. That one atom difference there means a lot. All right, are we good? All right. Well, that's chapter 10. If you got any problems next time, work those electron configurations and that. Let me know. We will start bonding sometime. I don't know when.
Would you say the OF was?
What's that now?
Would you say the OF oxygen had +2?
Mm-hmm.
Because why?
Fluorine is always -1. It's that rule up there that I said always.
You called it. You said oxygen has a +2 when usually it doesn't because
It's with that fluorine. Fluorine takes priority. And in your next chemistry class, you'll have a set of rules, and they will be in order. And if you have a conflicting rule like oxygen and fluorine, you always pick the rule that's got the highest priority. Well, guess what the top rule is? Fluorine has a -1 charge. Fluorine pulls rank on everything. All right.